Now, good morning, friends. So we are discussing sequencing. Sequencing. What is sequencing? Suppose there are n jobs, one, 2, 3 to n, each of which has to be processed one at a time at each m number of machines, A, B, C, and so on. So the order of processing each job through each machine is given. Suppose if you take the sequence A, B, C, that means whatever jobs we have in hand, first it has to be processed on A. The semi-finished product which is coming out from A has to enter B. From B it has to enter C. This order of processing a job is given. That we cannot change. But the number of jobs in hand from 1 to n, whether you process one first or two first, it is left to you. So you have to take the sequence such that the problem here is to find a sequence for processing the jobs so that the total elapsed time for all the jobs will be minimum. I have to process all the jobs from 1 to n on all the machines from A to uh, m number of machines. So finally all the jobs should be processed on all the machines, but the total time elapsed by these jobs should be minimum. Now, taking the problems, now n jobs through two machines. Here, Johnson's algorithm is followed. We'll see how the Johnson's algorithm flows. Here, n jobs through two machines. We have jobs number 1 to 5. These jobs to be processed on the two machines given A and B. First, it has to be processed on A and then it has to be processed on B. Whether you take the job 1 first or job 5 first, it is left to you. But finally, all the 5 jobs should be processed on these two machines, A and B. There are 5 jobs, each of which must go through these two machines A and B in the order AB, as I said earlier. The processing times are given below in the table. The processing times given in the table may be in minutes, hours, or days, whatever it is. So accordingly, the final answer should be expressed. Now it is asked to determine a sequence for these 5 jobs that will minimize the total elapsed time. Now, the first step is that the smallest processing time is to be searched for the jobs given on both the machines A and B. So here the lowest processing time is 1 among all the times given in the table. So that is on machine A and for job 2. So here, so if you see the given table, so it is on a first machine, and it is for the job 2. So the usual practice is when we have to perform n number of jobs or n number of activities in a project, for our convenience, we usually take the simple jobs in the beginning which consume less time. So and will take the tough jobs or the difficult jobs in the middle, and will conclude our project by taking the simple jobs at the end once again. So simple jobs in the beginning and end, and the tough jobs in the middle. So that is the usual logic we are having. So now the lowest processing time is 1. So that is for the first machine. So for on the job 2. So since it is for the first machine, so we are following the logic that the simple task to be taken in the beginning. So since it is for the first machine, so this job number 2 has to be sequenced in the beginning. If it would have appeared in the second machine, I would have sequenced in the last. So now it is for the first machine and it is on job 2. So job 2 is to be sequenced in the beginning here. So now job number two's work yeah, sequencing is over. Now the list reduces to four jobs. Out of five jobs, already I have sequenced job number two in the beginning. Again, we have to search for the smallest processing time. So here, so that is 2 here. So that is for machine B. So on job 1. So now we are keeping job 1 in the last since it is for second machine. So it has to be sequenced in the last. As I said earlier, the logic is taking the simple job in the beginning and simple job in the end. So since the second machine is taking its job once it comes out of machine A. So job number 1 is sequenced in the last. The next smallest processing time is 3 for job number 4 here. So that is job number 4. It is on first machine A. So it has to be the job number 4 has to be sequenced in the beginning. So already 2 is kept in the beginning. So then comes 4. So finally, the sequence using this logic, the sequence obtained finally is 2, 4, 3, 5, 1. So if we follow this sequence, so then the total time elapsed will be minimum. I have completed all the jobs from 1 to 5, but the sequence followed is 2, 4, 3, 5, 1. But the order of processing on the machines is that first if you take any job, it has to be processed on A, then it has to enter, the machine A, and then it has to enter machine B. But the job taken for performance is first is 2, then 4, then 3, 5, and then 1. We'll see what is the total time elapsed and idle time. So the first job process is 2. So it is entering my machine A on the 0th hour, and it takes a minimum of here so 1 hour. So the time given is in hours. So it get processed there for 1 hour. So it comes out on for machine A on first hour. Then it will enter machine B after 1 hour. So the in is 1 now. It gets processed there for 6 hours. So 1 plus 6 is 7. Similarly, if you take the next job, so immediately when the machine A is free, immediately I am taking the next job. So that is entering on the first hour. It gets processed there for 3 hours. So it is 1 plus 3 is 4. So even though this is coming out of a machine A on the fourth hour, still the previous work is going on in machine B. So this particular job is entering machine B on 7th hour. It gets processed there for 8 hours as per the table given here. So it is now 7 plus 8 15. So like that we are going to complete this in and out times for both the machines. So finally all the jobs given are over on the 30th hour. So then here the idle time that is each machine is kept idle. Here the first job is entering machine B only on the first hour. So for the first 1 hour, so it is idle, so that we are writing here. So then here we have the difference of 23 and 22. So 1 hour it is kept idle, this particular machine B. Now all the jobs are getting over on machine A on 28th hour, but I will say that my project get concluded on 30th hour. So 30 minus 28 is 2 hours. So here 28 minus 27 is 1 hour for machine B. So I am taking the total idle time for on these machines A and B. So it is 2 for machine A and 3 for machine B, and total elapsed time is 30 hours. Thank you.